Okay guys, so for this week I'm doing a experiment. We're going to see how this balloon with full of air reacts when I put it under, put fire under it, and then we're going to see how a balloon filled with water and air reacts when I put fire under it. So first, here's the one with air. Okay, so we saw how that worked. Now here's the one with water. Awesome. So as we just noticed, the balloon with nothing but air in it, as soon as I put the fire under it, it completely burst. And then once I put the fire under the water in the balloon with the water and the gas, it didn't explode like the one with gas. And if I were to, I don't want to do it because then I'm just going to make a mess, but if I put fire up here on the part without any water in it, it would just burst like that did, and it would just leave a watery mess everywhere. So the reason this is happening, so fluids and gases are less conductive than solids. And this is largely due just to the just because of the large distance in the atoms of these different states of matter, like in fluids and then especially gases. There's larger distance in the atoms than there are in solids, making it less conductive. So basically what that's just telling us is when the atoms are closer together and there's more collisions, there's going to be more conduction, and then vice versa. So when the water inside the balloon is placed on the fire, the water does most of the work. The water will absorb most of that heat rather than just putting it straight onto the rubber. So when the water is absorbing the heat, it's keeping that rubber around it fairly cool. But as for the balloon with nothing but air in it, it didn't have that water in it or anything to absorb the heat to keep that rubber cool. So almost instantly, the rubber heated up to a certain point that it couldn't handle, and therefore making it burst. So the water is what we would call a particularly good absorber. It's really it's a lot better at absorbing the heat than it is the gas. The water is able to take the heat and kind of hold it in, whereas the gas, it just meshes with it and causes it to blow. The fact that there was less collisions in the gas causes the water, or not the water, it causes the fire to spread rapidly throughout the rubber, and where there's liquid, the water is not, it's holding it in that different area there. When we have the water here and then we have the gas up here, the water is able to absorb what is down here, but obviously when we're putting the gas in the flame instead of the water, that gas is not going to be able, that water is not going to be able to absorb the fire or the heat that's being placed above it. So something I kind of wonder for myself is if I were to keep the flame under the water for a certain amount of time, if it were to cause it to explode because it couldn't hold it in anymore. It might take a while, but maybe it's a idea for another experiment.